This is going along with lecture 6, homework 6A. One example that we want to do is to write 4/5 as a decimal. So we want to take what's a fraction and get it into decimal form. We start with 4, we divide by 5. So we have our 4 over here that we're starting with, we're dividing by 5. I'll put a decimal point behind the 4. 4 is too small to divide by 5, so I have to put a decimal, make it 4.0. I'll put the 8 up here because I know 40 is 8 times 5. Go 8 times 5, create my 40. 0 remainder, answer 0.8. You don't have to put the decimal behind the 0. You can begin with the decimal point, but make sure that I can see the decimal. You can't do this, right? You can't go like, and then say maybe put a tiny dot there and a tiny dot there and put 7 and think you're getting 2 answers out of it. Now because you're doing this online, you won't be able to get away with that anyway. You gotta put the decimal in only one place. But I recommend you don't try and ever do that on paper either. Take a stand with where your decimal is. Number 2, we wanna write 3 3/10 as a decimal. I'm going to warn you not to do something that a lot of you will do. Remember, you're here to learn how to do this the best way to build a strong foundation and understand what you're doing, not to show off what you learned earlier and say, look how great I am. We're here to get this the best way we can. 3 is done as part of this. This is actually 3 3/10 is equal to 3 plus 3/10. Therefore, it's a 3 plus whatever we get when we divide 3 by 10. So here I put my decimal behind my 3, I turn it into 3.0, now it looks like 30. I can't do 3 divided by 10, but 30 divided by 10 will get me a 3. 3 times 10 gets me 30. Do the subtraction, I get 0. This is 3 plus 0.3, 3.3. Remember what happens when you're adding decimals. You got your 3, you got your 0.3, that's 3.0, that's 0.3. Go ahead and add them, 3.3. So the 3 didn't need to become 33 over 10 as part of an improper fraction and then come back down with more division. 3 is 3. That's your whole part. Only deal with the decimal. Number 3. They want you to write 88 over 50 as a decimal. So here, we don't start with this being 138 over 50. So we'll go ahead and we'll deal with their 88 divided by 50. We're going to continue until the decimal terminates or repeats. We hope it terminates. We hope it terminates early, but we're going past the decimal point in here. We're not going to throw the remainder over the divisor as we've done in the past. 8 cannot divide by 50. 88 has one of them in it. 1 times 0, 1 times 5. Subtraction gets me, that stays 8. This becomes 38. Smaller than 50, good. Positive, good. Positive means that I didn't take away too much. Smaller than 50 means I didn't take away too little. The 1 is a good digit. Bring down this now as 88.0 to make 380. Okay, 38 divided by 5. Think of 35, which is 7. 7 times 0 is 0. 7 times 5 is 35. 0 minus 0, 8 minus 5. We've got 30 now. Another 0, making 88.00. 30, when I bring down this digit of 0 in the hundredths with a TH place, lets me look like 300. Now I can put my 6. 6 times 0 is 0. 6 times 5 is 30. 0 remainder. We are done. 1.76. Write 4 5/9 as a decimal. Okay. 4. Right, it looks like this. 4 5/9 as a decimal. This is going to be a repeating decimal. They're a little bit more annoying. We have to know when we find the repeating pattern. We're going to put the bar over the portion only within the decimal that repeats. We're not going to have to write, for example, 0.777 and put a bar over all 3. If it's a repeating 7, we'll put 0.7 and let it know that the 7's go on forever. A repeating decimal actually means that it's over that many 9s. Someone had shown me this. I could demonstrate it in algebra at the end of the course when we're done solving algebraic problems, but let's go and see what we have here. We have 4 plus 5 over 9, which is 4 plus whatever this thing is going to make for me. I'm starting with a 5 and dividing it by 9. So above the 5, I don't have enough with 5 to divide by 9, so I have to go 0 point, and now let's make it look like 50. Okay, 50 divided by 9. I could probably get, I can't get 6 of them with 54, but I can get 5 of them. 5 times 9 is going to get me 45. Okay, so what we see is when we do 45, this becomes 40 and 10. 10 minus 5 is 5, that's gone. And we'll bring down another 0. You may not recognize the pattern yet, but that's going to be another 5. We'll get me another 45 and create another 5. And it's going to keep on doing that, so it's going to be this. And I'm going to run out of ink before I run out of getting there, right? It's going to keep on going through that cycle. What this is 4 point, the 5 keeps repeating. It's a single digit repeating right after itself. I put a bar over it, and that represents what I have. Now, what I said a few moments ago was that that represents this number over that many 9s. So if it was like 4.5 and the 5 is repeating, it's 5 over a single 9. If it's 4.57, it's 57 over 2 9s, 99, and that's where that's going to go. But that's how we'll handle repeating decimals. And let's get some more stuff. We'll keep the flow going here. Remember, you can always slow down, rewind, rewatch, whatever you need, because it is there. You don't have to say, oh no, we erased it. Convert 2/7 to a decimal. But then instead of making you go until it terminates or repeats, they're going to say rounded to thousands. So to the nearest, and then they write 1,000, and then they TH it to make it into a portion of the decimals. So it's the thousandths position. So what we're going to do is we're going to take 2 and divide by 7. Now we get to start with a decimal, so we can have this working 2.0 to get ourselves going. We want to go to the thousandths, so that's going to be 3 decimals. Places. We're going to look at 4 to keep 3. Here we go, the first one. 3 is too big, would make 21. Give me 2. 2 times 7 is 14. Subtracting, this is 1 and 10 minus 4 is 6. So now I go to 2.00. Bring down the 0. I don't have 63, so I'm not getting 9. I'll get 8. 8 times 7 is 56. So 60 becomes 50 and 10. 10 minus 6 is 4. 2.000 will allow me to have this as 40. 42 is too big with a 6. So 35 will work with a 5. 5 times 7 is 35. So bring this down to 30, and 10 minus 5 gets me 5. 2.4 zeros. Here we go. I'm going to bring down this 0. 49 is what I get if I use a 7. So 2.857. 7 times 7 gets me this 49. Now I can stop because I have all these digits. I have point, there's my tenths, there's my hundredths, there's my thousandths, which is going to be the last written digit, and then I have that. I look at the 57. See, I'm trying to round off this 5. It's either going to be a 5 or a 6. Rounding digits, I look at the 57 that makes. Nothing else after that matters. 57 is more like 60 than it is like 50. So I turn that into 0.2860. And now it's clear with the 60 I can drop the 0 because I was very close to being at the 6 anyway, and I'll get 286. And this is going to get me 0.286 for that decimal, rounded to the point where they asked me to. They want me to fill the blank on a couple of these. 6. Fill the box with equals, less than, or greater than. And we have 5.5 is one of them, and 11 over 2 is another, and the box goes in the middle. Now 5.5 is all established as a decimal. I can probably make this other guy into a decimal, see what we got. We've got 11 divided by 2. There's none in the tens place, but over the ones I have 5 of them. 5 times 2 is 10. I have one left, let's go for decimals. 11.0 lets me work with this as a 10. So now I can say what we've got behind the decimal is another 5. 5 times 2 is 10, and that's done. So now this is comparing 5.5 with another thing written in decimal form, 5.5. They're exactly the same, we go with equal. What I do generally to compare them is I leave one as it is, and I write the other one under it, lining up the decimal places until the tie is broken. The first one that is smaller is the one I'm going to point at. If they're equal, I'll have to stay with an equal sign. So let's try 0.04, well, sorry, 0.4 versus 0.4 that repeats. All right, so this guy is 0.4. And this guy over here is 0.4. They're still tied. The next digit for this guy would be a 4. The next digit for this guy would be a 0. Here's where the tie is broken. This one is less. 0 is less than 4. We're looking here in what's called the hundredths position to see the tie is broken. Point at the one that's less, point at the 0.4, not the 0.4 that repeats. And that's what we have here for our initial work on expressions and rounding. So that'll wrap up homework 6.